my name is Amrita Bhatnagar. I am from CSE department of AKGEC. Today I am going to discuss a topic from the unit 4, paging and virtual memory. These are the contents of the lecture: introduction to paging, memory management unit, logical address and physical address, translation look-aside buffer, virtual memory, page fault, demand paging, and page replacement algorithm. Okay, firstly we will understand what is the meaning of paging and why we use paging. In operating system, paging is a storage mechanism used to retrieve processes from the secondary storage into main memory in the form of pages. The main idea behind the paging is to divide each process in the form of pages. The main memory will also be divided in the form of frames. One page of the process is to be stored in one frame of the memory. The pages can be stored at the different locations of the memory, but the priority is always to find the contiguous memory holes. Pages of the process are brought into the memory only when they are required, otherwise they are reside in the secondary storage. Okay, we will understand the concept of paging with the help of a diagram. You can see here, this is the one process which is divided into pages. These process is divided into 6 pages, equal size of 6 pages. And now you can see here, this is the main memory where we have a portion for the operating system. You can see here, this is a portion reserved for the operating system in the main memory, and these are the frames, equal size frames in the remainder section of the main memory. Okay, but the main thing is the size of the frame and page will be same. Size of the page and frame will be same, so that one page can come into the one frame of the main memory. This is the concept of paging. So when we divide a process into pages, we need a memory management unit to convert the address of the pages to frames. Okay, then we have two different type of addresses: logical address and physical address. You can see here, memory management unit. Okay, when the memory management unit is to convert the logical address into physical address. So we should understand what is the meaning of logical address. The logical address is the address generated by CPU for every page, while the physical address is the actual address of the frame where each page will be stored. Okay, so address of the page is known as a logical address, which is generated by the CPU. But the actual address of the page which is stored in a particular frame, so that this address is known as a physical address. To convert a logical address into physical address, we need a unit which is known as a memory management unit. Fine, you can see here the example of the logical address, where we have a logical address which is divided into two parts. First one is the page number and second one is the page offset. In the page number, it is given the page number 1, 2, 3, or it can be any number. And when we find out the page number, then we will find out the particular line in the page. Then it is known as a page offset. So logical address is divided into two parts. First one is the page number and second one is the page offset. Fine. Now you can see here how we can drive physical address from the logical address, or we can say how we can convert a logical address into physical address, because CPU will always generate the logical address, it will not generate physical address. So we have to convert this logical address into the physical address with the help of memory management unit. Okay, so you can see here, this is the page table. When we are talking about the paging, then memory management unit is page table. Now question is, what is the meaning of this page table? You can see here, CPU will generate the logical address where we have page number and off page offset here. Fine. So in the page table, we will keep the information about the frames, because these pages are stored in the physical memory and it is stored in the particular frame in the main memory. So in the page table, we will keep the information about a particular page, in which page this, in which frame this page is stored. Fine. Then in this page table, we will store the frame number. For example, if the page number is 1 and page number 1 is stored in the frame number 3. Fine. So we will store the particular frame number of a particular page, so that we can find out frame number of a particular page. When we find out the frame number of the page, then we can calculate physical address of the main memory. In the physical address, we will have frame number and offset, frame offset. Frame offset and page offset will be same always, because the size of the frame and the page size will be same, so that page offset will be same here. So in this way, we can convert a logical address into physical address, or we can say we can find out a particular page and frame number into frame number. Fine. Now you can see another example for it. You can see this is one process which is divided into 4 pages. This is one process, and you can see here, this is a physical memory which is divided into 8 frames. Now the page size and the frame size is same here, and you can see 8 frames are there, and these pages will be kept into this physical memory. Now we need a page table or a memory management unit to keep the information about the frames and pages. Okay, you can see here 4 pages are there, 0, 1, 2, 3, 4 pages are there. So we can put, for example, this is the 0 number page. You can see here 0 number page is stored in the frame number 1. So we can have information in the page table frame number 1. You can see page number 1 is stored into the frame number 4. So we will have information about the page number 1, frame number 4. Another page is 2, which is stored into the frame number 3. So we have entry here 3, and third page is stored in the frame number 7. That's why we have this 7 number entry, frame number. So that by the help of page table, we can find out or allocate the frame number. We can find out a frame number, so that we can convert our logical address into physical address, so that we can find out the actual page which is stored in the frame. Okay. Now there is some problem in this technique paging. What its problem? This is the problem that this page table will also stored in the main memory, so that when a CPU generate a logical address, it will access, firstly it will access the page table which is also stored in the main memory. Fine. It will retrieve the page table from the main memory, then find out the frame number. Then when it find out the frame number, then again it will access the main memory to find out the original page. So there are 2 access in the memory, which takes more time. To reduce this time, we have another policy or another technique which is known as a translation look aside buffer. Page table is kept in main memory, which I have already told you. Page table base register points to the page table. Page table length register indicates size of the page table. In this scheme, every data instruction access requires 2 memory accesses, one for the page table and one for the data or information. The 2 memory access problem can be solved by the use of a special fast lookup hardware cache called associative memory and translation look aside buffers. Okay, so we have here to reduce the memory access or to reduce the memory access time, we need another hardware which is known as a associative memory or a hardware cache, which is also known as a look aside buffer. Now how we can use this look aside buffer in the paging technique, you can see here in this diagram. You can see here CPU will generate here logical address as it is generated in the paging. Now we have another table here, translation look aside buffer TLB. Here we have page numbers and frame number in the TLB. But problem is that where we cannot save all the page table. All the page table cannot be saved in this TLB because the size of TLB is less. So we cannot keep all the page records in the TLB. That's why we have a page table also there which is stored in the main memory. If the TLB hit will occur, then it means we have find out the frame number in the TLB itself. But if it is not find into the TLB, it means this is the TLB miss, and again we have to find out this particular frame number into the page table, and we have to access the main memory in this case also. Then in this process, firstly CPU will generate the logical address. The logical address, we will have a page number. We will find out the page number into the TLB table. If it is find out, it means it is TLB hit, and we have the frame number, and directly we will go to the main memory and find out the particular frame or page. But in the case where we don't have that page number entry into TLB, then it is known as a TLB miss. In this case, again, CPU have to access the main memory and access the page table and find out the frame number. So it requires two accesses. First, it will access TLB. If it is not in the TLB, then again it have to access the page table from the main memory. This is the main concept here. So if we find out the efficiency here, if the number of hits will increase, then this system will give more efficiency. If the miss will be more, then it will give less efficiency. Fine. You can say here effective memory access time in the case of TLB. The TLB access, for example, if the TLB access time is C and TLB hit ratio is X, it means how many times hits occur in the memory access. Fine. Main memory access time is equal to M. TLB miss ratio is 1 minus X. If the TLB hit ratio is X, then TLB miss ratio is 1 minus X. Effective memory access time, X into M plus C, which is the hit ratio. M is the memory access time plus TLB access time. If hit occur, then this time is required, X into M plus C. But if miss occur, then we require 1 minus X to M, because two memory accesses are required here, plus C. So effective memory access times will be X bracket M plus C bracket plus 1 minus X to M plus C. So this is the memory access time. Fine. Now we will see what is the meaning of virtual memory. Virtual memory is also connected with paging, because in the case of virtual memory we also use paging concept. Virtual memory in OS is a memory management technique that enables or allows the computer to execute larger programs or multiple programs together that would not be possible by using only the available physical memory. Fine. What it means, with the help of virtual memory, we can execute that program which are larger than main memory. How it is possible? It is possible by the help of virtual memory. In simple words, we can also say that virtual memory in OS makes an illusion of extra memory than available physical memory. Fine. So that we can have more, we can execute larger programs, larger games from the main memory. Memory size is small, but we can execute larger programs like any gaming application and another type application we can execute with the help of virtual memory. Virtual memory in OS organizes the physical memory in various parts and keeps notes of all the available and used memory, and it is also known as a page table. What it means? It means in the virtual memory also we use paging concept, where we have memory management unit page table. So we will use here page table to store the information related to frames and pages, because again here we divide the processes in the pages and main memory into frames, and we have a main memory management unit which is known as a page table, which keeps the information about the pages and frame numbers. Okay, you can see here we can have more than one different programs in the main memory, but we will have only that part of the program which is in this time is necessary to execute. So you can see here this is the secondary storage, and in this case we have two different programs, program A and program B, but we have only that program in the part of the program which is executed by the CPU, which is not executed by the CPU, which is in the secondary storage. So we will divide the program into different parts, and we will swap in the swap in that part of the program only which is executed by the CPU or which is required by the CPU. And when the requirement of the CPU is completed for that part, then it will swap out into the disk storage again. Fine. Now the question is, what is the meaning of page fault? Page fault dominate more like an error. A page fault will happen if a program tries to access a piece of memory that does not exist in physical memory or main memory. What it means? It means, for example, if this is a main memory and if CPU require a particular page into the main memory, but this this page is not available in the main memory, then this is known as a page fault. So we have to handle this type of problem also. If this page is not available in the main memory, then CPU have to wait for that page, and we have to keep this page into the main memory if it is not available this time. So this is known as a page fault. So now the question is, how we can handle this page fault? You can see this is the example for the page fault handling. For example, firstly, there is a need of a particular page which is known as a M. This is an equation. This is a instruction. And we need a page. Then we will see this page into the page table. If it is available, that is okay. But if this page is not available in the page table, what will happen? Then there is a signal trap will go to the operating system. Now the responsibility of the operating system to keep this page into the main memory, because this page is required by the CPU, and this time this page is not available in the main memory. That's why it is known as a page fault. Now the responsibility of page operating system is increases. Now pages on the backing. So now the operating system will go and see this page into the backing store or the secondary storage. Bring this missing page into the physical memory. This is the physical memory. If we have free frame. If it is not having any free frame, then we will apply page replacement algorithm here to free the frame and keep this page into the free frame. Now reset the page table. Now the entry of the, because now the page is in the physical memory, now the page table entries will be modified, or reset the page table and then again restart the instruction. Now when we restart the instruction, then this time this instruction will find out this page into the page table and physical memory also. Fine. So this by this method we can find out, we can handle page fault. So you can see here, when the page fault will occur, the main responsibility of the operating system is to bring the pages into the main memory or physical memory. Now the demand paging. What is the meaning of demand paging here? A demand paging system is quite similar to a paging system with swapping, where processes reside in secondary memory and pages are loaded only on demand, not in advance. What it means? It means we will keep that pages in the memory only which is required by the CPU. We will not keep any other another pages in the main memory. Fine. Demand paging in OS is a technique used in virtual memory management that enables a computer to use its physical memory more efficiently, so that we can use this memory more efficiently. Fine. Only the necessary part of the programs are loaded into the memory rather than entire program, which reduces the amount of physical memory required by the system. So when we take only required part of the program into the main memory, then we can use this memory very efficiently. We can give remaining memory to the other programs also. We can use multi-programming very easily here. Fine. By this diagram you can understand. I have shown you already this diagram. Demand paging system loads pages only on demand, not in advance. Fine. Instead of swapping the entire process into memory, the pages or lazy swapper is used. Lazy swapper means it will take only that pages which are required by the CPU. A lazy swapper brings only necessary pages into the memory. That is known as a demand page. Now the next topic is page replacement algorithm. Why we use page replacement algorithm? For example, if there is a page fault, and then we have to handle page fault, and we have to bring that pages into the main memory. But if the main memory is full, then we have to replace a particular page into main memory, because the page which is required by the CPU, it should be in the memory. So we have to replace one pages which is already in the main memory with the new page. Then what policy will be used here? So that's why we use page replacement algorithm. With the help of this page replacement algorithm, we can replace the pages in the main memory. Since the actual RAM is much less than the virtual memory, the page fault occurs. So whenever a page fault occurs, the operating system has to replace an existing page in RAM with the newly requested page. Fine. So we have to replace an existing page with the newly requested. In this scenario, page replacement algorithms help the operating system in deciding which page to replace. The primary objective of all the page replacement algorithm is to minimize the number of page faults, so that we can reduce page faults. The system will be more efficient if we have less page fault. So the main aim of the page replacement algorithm to reduce page fault. So we have different type of different page replacement algorithms here. First is the first in first out. First in first out means the first page which came into the main memory will replace by the new page. Fine. This algorithm is similar to the operation of the queue. All the pages are stored in the queue in the order they are allocated frames in the main memory. The one which is allocated first stay in front of the queue. The one which is allocated the memory first is replaced first. Okay. The page which is allocated the memory first is replaced first. That's why it is known as first in first out. So we will see here with the help of a particular string example. This is the string. We will see how this algorithm works here. You can see here we have, in the case of this example, we have 3 frames, frame 1, 2 and 3, and this is a string we have. And now how this page replacement algorithm will work? Firstly, we have empty 3 frames. So first element is 6. So when the 6 came here, frame 1 will be fill up, but this is known as a miss because we don't have 6 page into the main memory this time. That's why it is known as a miss. Next time 7 will come in the next one. Again this will be miss. Next time 8 will come, and again this is known as a miss. Now 9. Now the frames are filled. So 9. When 9 will come, we have to replace a particular page. But in this time we will replace, because we are using first in first out algorithm. That's why firstly we have placed the 6 page into the frame 1. That's why we replace here 6, and 9 will come here in the frame 1. Next is the 6, and now 7 will replace by the 6 page. Next is the 7. 8 will replace by the 7. Again 1. 9 will replace by the 1. 6 come. 6 already in the frame 2. There is no need to bring it into the frames. That's why it is known as a hit. This process is known as hit because it is already into the frame or memory. Fine. Next is 7. 7 is also in the memory. That's why again it is hit. Next is 8. 8 is not in the main memory. That's why we have to replace one particular element which is 6, because this is the first element which is we have allocated memory. Next is 9. 9 will replace 7. Next is 1. 1 is already in the main memory. That's why it is known as a hit. Fine. Now, there is a anomaly in the first in first out algorithm, bloody algorithm. In this bloody algorithm, what happens if we increase the number of frames? It means when we increase the memory, but number of page fault will also increase. This is known as a bloody algorithm. You can see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 Miss was there with the help of 3 frames. When we increase the frames 4, then what we will see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 miss was there. Page fault again increases when we increase the memory. But if this is not desirable, because we are increasing the number of frames, means we are increasing the memory, and if we are increasing the memory, then there should be less page fault in this algorithm. But this is known as a bloody anomaly in the first in first out. Next is the optimal page replacement. That's why, because of bloody algorithm, we will use different another algorithms, because it is not giving good efficiency to the system. Now string is same. Now we will use optimal page replacement algorithm. What is the meaning of optimal page replacement? In this algorithm, the page which would be used after the longest interval is replaced. In other words, the page which is farthest to come in the coming sequence is replaced. Means the page which will use after the longest interval is replaced. How we will find out? We will see the example. Firstly, string is same. Frame 1 will fail, then frame 2 will fail, frame 8 will fail, then 9. Now we will see 6, 7, 8 is already in the memory. We will check the possibility of which is longest interval will be accessed, which element will access after the longest interval. Then we will see here, you can see here longest interval is 6, 7, 8. We have, because we have 6, we have 7 here, but 8 will be in the longest interval, will be accessed in the longest interval. That's why we will change here 8. In this way, next element is the 6. 6 will replace, this already is in the memory, then it is known as a hit. 7 is already in the frame, that's why it is known as a hit. Next is the 1 will replace by the 9, because it is longest interval, it will access after the longest interval, and 9 will be replaced. So that's in this way we can use optimal page replacement algorithm. So we will check the references of the element in the future. If the element is the longest interval, after the longest interval it will use, then we can replace that particular element from the memory. This is known as the optimal page replacement algorithm. Next is least recently used. This algorithm works on previous data. Optimal replacement algorithm used in the future references, future data, but least recently used algorithm is used on the previous data. The page which is used the earliest is replaced, or which appears the earliest in the sequence is replaced. Fine. You can see here. 6 first miss, 7 second miss, 8 third miss, 9 Now we have to replace a particular element. So we will check least recently used. Abhi recently we have used 8, we have used 7, but we have used least recently 6. That's why we will change with the 6 here. Fine. Then 6 will be replaced by the 9. Now next is 6. We will again check in the case of 8, 7, 9. So we can see here 7. 7 is least recently used. That's why we will replace it with the 6. Again, we will see 7. 7 is replaced by 8 because it is least recently used element 8. In this way, we can find out all the miss and hit in the system, and we can calculate all the page faults and hit in the system. So these are the different page replacement algorithms. There are 3. I have discussed 3 page replacement algorithm: first in, first out, optimal, and least recently used. In this way, we can find out less page faults by the using of page replacement algorithm. Okay, thank you. I think you will understand this concept very easily by the help of this lecture. Thank you so much.